Our next presenter is Nathaniel Palmer. Nathaniel was rated as the most influential thought leader in business process management. And I met him first time when he was one of organizers, together with Bruce Silver, of a very popular event called BPM Next. Unfortunately, COVID interrupted this event, but I remember Nathaniel always did a brief presentation about what we can expect in the next 5 years. And actually, a majority of his predictions became real. And it would be very interesting to hear his view of the next 5 years in decision intelligence, what we can expect. And without further delay, Nathaniel, please go ahead.
Great, thank you, Jacob. Well, thanks everyone for participating. I'm really proud to be here. It's been a really enjoyable decision camp. I presented 2 years ago, although usually at these camps I'm more of a lurker in the background. But I've been working on something. This isn't a 5-year look at decision intelligence per se, although it's certainly related to that. But this is something that has been both a journey over a little bit more than a decade. When I first saw robotics as being something that was going to be the next big thing in our careers, as well as being really detached from the work that we were doing. And this predates what's happened over the last couple of years with Gen AI. But I had this sense, this prediction of the importance of robotics, and I see that now more clearly, but I also see that gap existing, and that's a lot of what I want to talk about today. This is not entirely theoretical. This is grounded in actual work, both research as well as development work that I'll talk about, both that I've been engaged in and observing, as well as a call to arms. And it's what I see as a defining area for this community. Now, as part of a call to arms, to start off, the framework that I've evolved, the philosophical framework I've evolved over the last couple of years or last decade or so, as it relates to automation, what I've described as ethical automation. Ethical AI was kind of an overused term and really dealt with the training of AI and the data that goes into it, and the notion of implicit bias in the training of models and training data. It missed the mark in that it doesn't look at outcomes, and it doesn't look at the notion of the increasing role of algorithms in decision making, where that decision making becomes opaque, unpredictable, where the same decision is not necessarily reached with the same set of circumstances, which in a lot of aspects of our life, it should be entirely unacceptable. And that is really the mandate for declarative AI, decision intelligence, having implicit declarative decisions that are explainable and observable in any outcome, so that we're not beholden to or at the mercy of algorithms for life or death situations. In the context of digital automation, that's pretty well understood. But now we have this growing imperative for another aspect of automation, which is physical automation, the automation of physical work. And the absence of that has led to increasingly dire work environments and work pressures, and all of what we talked about in terms of not just the drudge work that was being done in a digital context that we've been able to apply automation to, but even more complex work. Now, as we've expanded the aperture of automation to knowledge work and more complex work, we have the same issue facing us in the physical realm. And that is what is behind this imperative for embodied AI. And imagine as we're approaching a scenario where we have a super intelligent workforce that it costs us from a labor cost a fraction of what human labor costs us today, and a fraction of what we're looking at otherwise is achievable through physical automation. Because the reality today is that deploying physical automation has a huge capital cost. It's very expensive. There has to be a lot of repeatability for the business case, but that is shifting radically as we look at the role of humanoid robotics, general purpose robotics. We've clearly hit an inflection point, and we're seeing now the rapid evolution of those capabilities. From an economic standpoint, we're looking at what is undoubtedly going to be the largest market of our lifetime, whether it's truly a $50 trillion marketplace in the next few decades, or whether it's even a half of that or 10% of that. It will still eclipse virtually any other market that we've seen. But there will be more humanoid robots than there will be cars within the next decade or so, and within the next couple of decades, it'll outnumber people. It'll outnumber really any aspect in our life. It will be the defining paradigm shift. It's the one thing that we don't have precedence for historically, or even in any palpable sense today, the impact that this is going to have. So the actual market size is irrelevant to this discussion, but just understanding and buying into the fact that this is radically changing every aspect of work in the same way that AI is going to be a part of everything. This aspect of general purpose robotics, whether it's truly humanoid or other aspects of general purpose robotics, is going to be endemic throughout everything that we do today, and nothing will be the same as a result of that. But why hasn't that happened so far? And again, what we've faced traditionally is a very high capital cost, as well as technical costs. The training of robots is typically 5 to 10 times the actual cost of the physical capabilities. The integration with systems within the workforce is very high. That there's a lack of standardization. There's been a lack of interfaces that relate to the work that's being done by the actual devices. So there's this notion of more of X paradox, which has held back robotics, and just the simplest interpretation and definition of it is why robots learn to play chess before they learn to walk. Robots learning to walk has been one of the most complex and technical challenges, but performing complex computing and being able to do things like playing chess, that's been much easier. In general, because particularly in the case of robotics, I mean, this is applied to both AI in the digital sense as well as embodied AI. But the notion of the simpler a task is from a human standpoint, the harder it is to train a robot. The more complex the task is from a human standpoint, the easier it is. But it means that the opportunity is understanding how embodied AI, how robotics can accelerate in terms of not just its physical articulation, but its ability to learn, its ability to adapt, and to be able to make decisions appropriately in real time. And that is where the challenge and opportunity for us lies. And if we think of what robots have been to date, on the left we have what are articulated arms. I mean, that's that's a factory automation scenario, but where we see a high implementation cost, a high capital cost, and then a scale through repeatability, entirely deterministic, very narrow in what it's able to do, very predictable. There is no probabilistic or non-deterministic logic happening here. It's doing only what it's told to do, and typically programmed in a very narrow context. What we're seeing, that the inflection point we're in, is this notion of general purpose robots or embodied AI that is being driven by advances in the foundation models, having actual AI where this AI is absent in the traditional factory automation scenarios, to actually having the management, the engine that's driving the logic behind the robot being built in and around a foundation model, leveraging reasoning capabilities, multimodal integration, and this notion of behavior cloning. Just showing it as an example here, these are what are probably the most advanced humanoid robots today from Figure. These are the Figure 2s. And this guy is asking them to put groceries away. No other instruction. So the amount of programming complexity to have an articulated arm be able to pick up and put into a refrigerator would be enormous. In this case, it's leveraging behavioral cloning, being able to just show basic things, and then the robots in real time in this case. And this is one of the most remarkable things about this demo. If you've seen the longer video, there was no pre-programming around the coordination or cooperation between them. They both have the same basic instruction set. They both saw and were given objects that they hadn't previously been taught about, but they're able to figure out basic elements of where they should go. And this is another one where it's showing folding of laundry. But in these cases, the training and programming threshold is lowered dramatically. But we've shifted from robots that are entirely deterministic to, in this scenario and at this moment, almost entirely non-deterministic. So luckily, we've got the three laws of robotics, right? Thankfully, we know that no robot can injure a human being or allow a human being to come to harm, nor and it has a sense of self-preservation. So luckily, everything is founded in these laws of robotics. Obviously not. As brilliant as Isaac Asimov was as an engineer, this is science fiction. This does not exist in robotics today. Now, an interpretation of it, working with my colleague that many of you may know, Lloyd Dugan, we've come up with a BPMN model for the laws of robotics, actually created a DMN model as well, and then have codified those robotics. So we have each of the three laws here as decision tables. So here we're able to digitize and put into a machine, enforceable machine understandable instruction set, the laws of robotics. Robots need rules. Robots cannot simply be non-deterministic. The challenge is the models that are running, what's allowed for this inflection point, what has enabled robots to advance today is leveraging local computing, running neural networks that are completely opaque. It's entirely a black box. And that is the imperative, or the moment we're at today, where we, with robotics, are well behind where we are in digital automation and the governance around digital AI in terms of its explainability, its enforceability, and its predictability. Robots need rules not only to function in human environments. So this shift that we're talking about, moving to whether it's a $5 trillion or $50 trillion market, robots will be everywhere, and it will literally our lives will depend on humanoid and general purpose robotics. But today, with the current models in place, they are operating in the same manner with the same lack of governance as AI was, particularly over the last decade or so, without a clear set of either physical guardrails nor guardrails around logic, explainability, and on the instructing of robots. So that is the call to arms here, is that this is the, I think, defining opportunity for this community. We're not necessarily being invited to the table in the development of the operating systems and control environments for robotics, but there are entries that we'll talk about. And one of these notions in the realm of digital automation, one of the patterns that we had developed in going from what was previously purely deterministic to leveraging probabilistic models and services via Gen AI, but wrapping those outcomes with deterministic decision services. And this is this basic pattern which allowed us to leverage AI in areas where we could not otherwise be able to, either from a statutory standpoint, where we had from a legal or a regulatory standpoint, had to demonstrate the reasoning behind outcomes, but we were still able to take advantage of generative data and capabilities by applying that, where we're wrapping that service and presenting that as a decision service that's leveraging generative AI services. That is a model for enforcing the same level of explainability and accountability with robotics. The challenge is at the point in which we're going to insert that. Certainly, in general, as this market expands and frankly explodes, there's going to be leverage of both external AI services and decision services. So there's generally going to be the need for that. But talking more specifically about how we approach that today and where those points would be, it presents a new architecture for the internal compute capabilities for robotics, and where we're leveraging declarative AI, decision intelligence with knowledge bases and being able to provide that combination. So a distinction where we were able to model digital workers, and that was a big part of advances that when I say we, that in my own work with my extended team and work that I've talked about and given case studies on, but also true for the industry as a whole, for that shift from automation being simply a system or a system component to creating a model of a digital worker where the automation capabilities is able to log into the same systems, have the same rules, the same observability, have the same governance as human workers. That was a critical shift to enabling and expanding that which is automatable. That is the same philosophical approach with robotics. The challenge is there's simultaneously the management of the physical aspect, the locomotion of the robot itself, and the fact that we're not just, it's this multimodal notion where we have to be governing and instructing and informing based on touch, vision, hearing, as well as the processing of that, how those inputs translate to inputs that are then applied to logic and ultimately to decision models. So understanding a pipeline of having the perception layer, the declarative layer, and the execution layer, but also having all of that governed by explainability and safety. And explainability in the context of digital AI means what rules are applied. In the context of safety, now we have this physical dimension of a very strong, very heavy, and in just about every case, physical entity that we have to worry about its own safety as well as the safety of humans around it, and being able to not only ensure that it does the right thing, but that we are circumventing and not allowing it to take actions where it's law number one, being able to keep humans safe. So this is undoubtedly familiar territory for everybody here, and just talking about the notion of thinking in terms of perception, decision, action, and that perception layer opens up a whole new dimension with this notion of having an abstraction of the multimodal input capabilities, and then from the actual decision, and then from the execution. So two phases or two approaches based on where the industry is today and what we can do. The first one is, and I'm using it as I talk through this, the Helix environment. So Helix is the operating system for Figure AI's robots. I believe they started off using a version of OpenAI and then pivoted to their own model. And it's the most advanced that I'm aware of, and I say that with a pretty reasonable authority. For sure, Tesla, stuff that's coming out of NVIDIA, indigenously. There are others that are moving as quickly and may eclipse Figure right now. In terms of looking at a framework to understand the context of how decision intelligence and declarative AI would be applied, I would hold up Helix as the most advanced, and this notion of the vision language action model that defines it. So there is the model itself, the foundation model, the capabilities around it are pre-trained, of course. The robot starts up, walks off the assembly line. It has the vast majority of what it needs to be able to navigate the world. But there is the ability to train beyond that for enabling it to do basic things. So, for example, they've got, I think, Figure 2s. I'm going to say 10,000 humanoid robots that are working in the BMW plant in Spartanburg, South Carolina. And it's doing stuff that previously you would have robots like shown in the earlier slide of articulated arms that are just able to do very narrowly defined work. Now you have general purpose humanoid robots that are doing actual complex assembly. So there is additional training that goes to that. And one of the opportunities here is to apply the discipline around decision intelligence as well as around business discovery and task and process mining, and being able to leverage that which has been advanced in this community, which really isn't part of the current methods around training of robots. So that we could do today. There are inherent limitations to that. And part of that is, again, we're training neural nets rather than something where we can have that level of accountability and explainability. There's still a lot of opaque decision making going on, and it really shouldn't. It doesn't adhere to philosophically the point that I'm driving with this, or the call to arms for this community, but it's the starting point of applying decision intelligence to the training and governance around robotics. And again, the strengths and weaknesses here, it offers the ability for easier training because it's leveraging the behavior cloning and other aspects that make integration of logic easier than what was previously involved in the much more deterministic programming of robots. But the lack of observability and enforceability is a significant weakness. It really speaks to the need for a hybrid approach. So that the second phase, the evolving space of hybrid neurosymbolic integration, which is advancing in the broader AI space and in the digital AI space, but clearly applies and is clearly needed in the embodied AI space. And it's the notion of having dual models where there is some governance and enforceability, where they are working together, both one that is a traditional neural engine, then one with symbolic AI. And part of this is being able to extend the weighting of rules and areas of logic. So having adjustable rule strength as one of the implicit benefits of this. An example coming out of, if you were a fan or at least watched Westworld, and that's probably the most vivid illustration of humanoid robots in recent history, and the ability to adjust the behavior of the robots with this notion where you open up the control pattern, and in this case, they moved intelligence up to 11, and of course the robot took over the world. But that notion of having adjustable rule strengths, which is not available in the traditional model, but does present itself with this hybrid neurosymbolic integration. Looking at Helix, and this is just taken from Helix. This is not my own, and taken from Figure. This is not my own research. This is just explaining how they have the two working together, and where they've got two parallel but discrete systems. The S1, which is the vision language model, and the S2, which is the visual motor transformer. They're combining interpretive reasoning or making non-deterministic decisions, but still having the deterministic enforcement of physical behavior. Just showing an example of how those work together with the basic thing. So in that scenario where they're putting away groceries, there is adaptive reasoning that's happening on the fly, but there's also deterministic logic that's being enforced around the physical actuation and the management of locomotion, knowing how to move, pick things up, and walk. It hasn't been applied to being able to have that abstraction of behavioral rules that in the same way that we're we're talking about here, but the architectural model is there, and the opportunity for that to be defined and refined and expanded by advances in decision intelligence. That is the opportunity for this community for the enabling the advancement of robotics. And the strengths on that are and weaknesses are pretty straightforward. But again, it's that the notion of having the abstraction of the perception layer and having that be in the context of Helix, that's largely governed by the visual language model, and it is non-deterministic, but is constrained by a system or a second engine where the symbolic AI enforces actual declarative rules and pre-programmed deterministic capabilities. This is a model that a reference model that's come out of some work that the McKinsey did, and just talking about this basically shows that the different subsystems of what's happening inside of this is the local compute, local running environment. And in this case, and this is part of it, I don't have a reference in here for it specifically, but if you look at the recent announcements from NVIDIA on what they are enabling with training of robots through simulation, where it is the same behavioral cloning capability, but rather than having to observe or go through physical paces, they're using simulation data, and that's if you've seen videos of this or otherwise, where you've got robots that are able to move from very clumsy to highly dexterous capabilities without actually having to physically train, but getting this entirely through simulation. That is one of the advances in these capabilities, but it's also where we can put in place the control points and governors around the actual behavior. And as we're wrapping up, so the symbolic versus probabilistic or machine learning approaches, the reality is we're at the early stage of these working together. The hybrid model is undoubtedly going to be the defining model. We're applying it in more narrowly defined scenarios, but this is where the enforcement of decision logic, having robots in the workforce be able to interact based on local rules and policies, not have to have that entirely trained, where they're able to show up on day one for a job and to be able to develop an understanding of both performing work, but also the boundaries, the governance, the control points around how that work is performed. And ultimately to be able to have that with greater observability or accountability than human beings, because we're have the opportunity to remove that subjective decision making that otherwise is happening with the neural model. So the future of human robotics, which again I am absolutely convinced is going to be the largest, the most exciting, the most both disruptive as well as impactful industry of our lifetimes. The future of that is to be able to not simply advance the way that it has been with foundation models, but to do it in a way where we apply the same accountability, observability, and transparency around decision making that will be necessary for both human trust, but also from a regulatory standpoint, there will be undoubtedly an explosion of regulation and other policy around what robots can and cannot do, clearly beyond the three laws, and the enforceability of that is going to be critical to the growth and success of this, to ensure that every automated outcome, every outcome performed by a robot in the same way as with digital automation, that it's observable, explainable, and accountable. And Denny was talking about this in the very beginning of the DecisionCAMP in his presentation, the notion of the human in the loop, and that we can't hold AI accountable for decisions. That ultimately that comes down to a person or a legal entity. But the reality is, with humanoid robots, with autonomous vehicles, with embodied AI that is physically manifest, we're going to have to shift to a model of accountability where it is accountable. There may be a corporation, maybe an individual behind it, but there has to be enforceable accountability to the entity that's able to take that action. And that is the critical opportunity and the imperative for this community. But the last point that I want to wrap up on, I would be remiss if I didn't talk about a group that my organization has recently joined, that is a working group outside of the Twain Standards Organization. But this is Cricket's, the consortium for integration of, in this case, it's focusing on creating a foundation model that is workable across different robot platforms to be able to perform MRO on, initially the use case was the MFP space, but expanding that to other areas, not factory floors, not warehouses, but general business scenarios, being able to expand so that functions can be safely performed by robots. So it's an early stage group, and it's our involvement, and it's even earlier or more recent. But it's an area that I would encourage to look at and stay abreast of the developments there. It's one of the most exciting organizations that I've been involved with recently. So cricketsus.com is where you can get more info. My slides have been updated from what's online right now, but I provided these, and there are some hidden slides that I didn't go over here. I'm going to make sure that we had enough time for questions. But in the larger deck that'll be online, there's other information, that just some general reference data on some of the things that I've been talking about. So with that, I am going to go back to you, Jacob.
Okay, thank you very much, Nathaniel. I'm sure we will have questions.
I'll go first if you like. Thanks, Nathaniel. Enjoyed that. I think you're absolutely right in homing in on the area of interest to us. I remember I worked for a couple of years in robotics 25 years ago, and we were working on things like sensor fusion and nonlinear planning, which seemed really hard at the time, and now they're basically cracked, all of these sorts of issues. I think you're right in focusing on how we achieve understanding between robots and people. And thinking about iRobot and the rest of the robots, that what made those stories amusing was that he wasn't actually saying that these rules would suffice. In fact, he was saying the opposite, that every story was about some situation in which the rules failed to work properly. I remember one particular one that was a disgruntled human employee told a robot to get lost, and so it did, for example. So I think I'd be interested to know what you think about how we're going to crack this issue of humans and robots actually understanding each other, disambiguating situations and intentions and so on.
Yeah. That is a great point, Alan. And that notion of intention, and that there was some, well, I think, did you speak to that earlier? I know there was some discussion about being able to represent intention more formally, and that I've not applied that lens to looking at this notion. The general notion of disambiguity, yes, and how critical that is when we move beyond folding laundry and putting away groceries to relying on behavioral cloning as a primary means for instruction. Ambiguity and intention become pretty critical. And but I don't have a solid answer for that at this point, but it needs to be on the list for it exemplifies why this community needs to be part of that discussion that's not really happening today. I mean, places like Foundation and others, when they're hiring lots of brilliant engineers that undoubtedly are fellow travelers with this community. So it's not like it's totally separate. I'll tell you, my journey with robotics, other than always fascinated. I mean, you can't be technically oriented and not be fascinated by robots. But kind of the inflection point for me, I used in lots of old decks. It's now I've kind of dropped it. But you've seen a picture of when we had the two popes announced and the crowds waiting there in the square, and you had like I can't remember the exact dates, but let's say it was 2004, and just crowd, everybody there. And then the next one, which is 2 years after the iPhone was released, it's just a sea of screens. And it was a great illustration on how that changed. And I started thinking that I really missed that shift. I was an early adopter of the iPhone, but I didn't understand the impact of mobility, partly because I started looking at it pre-iPhone and, really was not a big fan of mobility because the capabilities were so limited. The use cases were so narrow and uninspiring, but it absolutely changed just about everything to our relationship. We now see the world through our phones. We behave, it's far more than just changing communication patterns. It changed everything. So around that about 5 years after that, around the 20, well, I can pinpoint it to 2012, I started thinking, well, what is the thing that's going to change next that we're not seeing that's maybe 5 years out, 10 years out? And so I thought when we hit the inflection point with robotics, or it becomes less about the mechanical controls, more about software, that's going to be the next big thing. So I started in getting involved in that, and went to at the time was kind of the premier conference on robotics it's called RoboBusiness, so the business application of robotics. Convinced him to let me speak the next year, and I was really pushing this notion of there's a whole world of event-driven software architecture that you guys need to know about, because you're so much cost and constraint is around these very proprietary operating systems, and even that notion, that perception layer, which is and will continue to be so critical to the advancement of robotics. Getting beyond that to being able to understand it as events, and to be able to respond to events and put context around that. That there's a whole community that's figured all this stuff out that you're barely looking at it, and the proprietary environments that are still in place today, but are quickly being leapfrogged by like Figures, Helix, and others. But for a decade, those environments were so antiquated compared to what the rest of the world was doing. Even the robot operating system, the ROS, which is an open source kind of an event-driven, it was there to be able to be leveraged and expanded upon. But very little work was done on that. And now that's clearly the defining space. meaning we've hit that inflection point where software is determining the success, the growth, the capabilities more so than the physical side. And talking with the CEO of Figure, one of the points he made is which is sort of an obvious thing, but it wasn't quite obvious to me until he had said it, that you can fail fast and in the software space do all the things with rapid integration, rapid innovation. You can't do that in the physical realm. You can't fail fast, physically. But you saw that over the last decade with the various videos we've seen of stumbling robots, and then the DARPA challenge was one of those inflection points. But the need to get that accurate in the physical space, because you can't adapt it unless it's software defined. So that notion of tying adaptability to software defined capabilities, that is what is enabling the acceleration of this, by orders of magnitude. So tying that back to the point of ambiguity and understanding intent, clearly that has to be a priority. And even and we're going to start to run into all sorts of obtuse regulation coming down from various parties that really don't understand the engineering behind it. That notion has to be part of it as well. And that's, as the point I made at the beginning with ethical AI and how all of the AI regulation really misses the point that it's the outcomes that matter. Biased data doesn't matter unless it's an unfavorable outcome. And overall, that means the same circumstances, the same outcome, 1,000,000 times in a row. And with articulated arms, you get that. With humanoid robots, you don't get that. And that has to be the starting point. And then you have the additional issue of that notion of it interpreting instructions correctly, because now you have ambiguity and failure to interpret intent, and the robot gets lost, or it kills somebody, or it does something else because all the logic checked out, but it just misunderstood its actual mission at that moment.
Okay, we have a comment from Lloyd in the chat. Probably just a comment. People can read it.
What do you say?
Okay.
Oh, okay. Well, everybody can read that.
Yeah. Okay.
There's largely
more
echoing
questions?
out point.
Okay. If we don't have question, I just will make one more comment. What is really enlightening? We usually are software people and don't know a lot about hardware, but I clearly remember meeting director of machine learning lab from MIT probably 17 or 18 years ago, when he explained how difficult teach a robot to work, exactly what you said. And this was, and if you look on progress, what was 18 years ago and what we have today, just amazing. And you said that teaching computer to play chess much more easy than do this to teach a robot. And if we look on the progress between Deep Blue that beat Kasparov and what we have today on our computer chess programs that have self-learning opportunities and beat everybody, this is gives us optimism that our software decision intelligence systems will go far beyond current generative AI, and in 5-10 years we will see huge progress, similar to progress with robots, and maybe robots even will give us incentives to move in this direction, right?
Yeah.
Okay, Nathaniel, as always, it's very interesting, and thank you very much for coming and sharing your vision. Okay, thank you.